Ooh. Well, hello. Seems my stream is working again. Am I loud enough this time? Does not look like it. I'm gonna make myself louder. Input devices. This should do it. Oh yeah, let's go. Gonna mute my own stream. Okay. So, let's see what we did last time. Keyboard and software. Software, okay. Let's see. USB driver. Okay, yeah. Last time we set some bits to select the right clock. Basically, we set the configuration for the USB, and here we enable the USB. Now, today I want to set up the control endpoint, which would be endpoint 0 and controlling basically the device properties of the keyboard. So in this case, it would accept the setup commands and send appropriate responses. Endpoint activate. Okay, yeah, we need to USB controller. Let's wait, no, operating modes. Yes, endpoint 0. This is what we want to do. Okay. So USB device controller states after reset. We have the reset. And then we can put it into idle with USB E1. I think we already did that. No, USB con. Wait. Is that the right one or is it not? USB con. USB E. Yes, this is 1. So back to this one. And UID. What is UID? Is UID somewhere here? This is not UID. Not UID. Okay. I'm guessing we're gonna find out. So the reset state is the macro clock stopped. Wait, yeah, this is this one. But we are already here. Wait, no, we don't have the UID. The UID somewhere here. Register description. You know what? We're gonna UID. UID this way. Okay. Okay, no guidelines. Kind of unfortunate. Oh wait, UID is a pin. Which pin is UID? Schematic editor. USB control. Let's see. There is no UID. U ground. Well, that's not helpful. UID. So I'm guessing it's gonna be somewhere here. UID. That did not work. Is there no UID? This seems like something we would need. Just a quick guess. Well, I'm not fine. I'm not seeing it. Try again, UID. And nope. Well, yeah, I'm gonna go back here. And the endpoint blanks are reset. D plus pull-up are not activated. D plus pull-up will be activated as soon as detach bit is cleared. Is this USB detach? I don't think so. The macro is set idle with a minimum power consumption. Okay, yeah, good. It's not gonna be idle for a long time though. An endpoint can be reset at any time by setting the UERST register bits corresponding to the endpoint. This resets the internal state machine on that endpoint. Internal state machine? What? The TX and RX blanks are cleared and their internal pointers are restored. The somewhat registered are restored with their reset value. Yeah, cool. When USB is reset, the next operations are performed by the controller. Minimal duration of 100 microseconds. That is not very long, I think. Prior to any operation performed by the CPU, the endpoint must first be selected. Yeah, kinda makes sense. As endpoint enable bit is not set. Okay, yeah, makes sense. Following flow must be respected. Oh, we have a flow, let's go. So select the endpoint. You enable something, endpoint number. Register description. You enable number. Let's go. We want this to be 0. I think. Yes, for 1.0 we want this to be 0. So far making sense. This register selects the target endpoint number for a lot of registers. Okay, so we're just gonna set this one to 0. Yep. I don't know how I messed this one up. I wanted to press P like a normal person. Wait, I don't need this. I can just set this one to R0. Yeah, maybe. Yeah, I'm gonna write. What does it do? It selects the endpoint. Maybe. Oh, do we have a viewer on Twitch? Let's go. Yeah. Select endpoint. Yep. And next step. Let's go. Activate the endpoint. Yeah, that seems pretty straightforward. EPEN. Where do we have that? EPEN. USB endpoint control register. Yeah, that seems. What do we have here? Writing this bit to 1 allows the USB controller to generate a stall answer for the next setup transaction received. This bit is cleared by hardware. Okay, yeah. So we can stall the setup. Writing this bits to 0 has no effect. Stall handshake can be. Oh, okay, yeah. What does it do? Send a stall handshake to the next request. Yes. Each time the stall handshake is sent, the stalled I flag is set by the USB controller and the EPINT X interrupt will be triggered. The incoming packets will be discarded. Okay, so we can basically, this is basically the currently calculating value in case something's coming. This clears it. I'm seeing this correctly. Yeah, stall request clear handshake bit. RSTDT, reset data toggle bit. Writing this bit to 1 allows to reset the data toggle bit field. What? Yeah, wow. It's a name. Okay. For the selected endpoint, yeah. What does it do? This bit cannot. Yeah, it's cleared by hardware. Okay. Reset data toggle. Just gonna leave that on standard for time being. I think I'm just gonna set this to 1 and enable a stall request request stall handshake. I'm just gonna set it to 1. Yeah, just 1 and see what happens. So which one was it? Control X. And this one has to be 0, 1. This one has to be this. And this one, what does it do? Oh yeah. Enable endpoint. So, yeah. Safety first. So configure. Boy, now there comes the complicated stuff. So we first have to endpoint direction and endpoint type. I think the type is fixed on the control endpoint because it's the 0 endpoint. The not yet disable feature. What the fuck is that? Do we have some information as long as the endpoint is not correctly configured? Yes, the hardware does not acknowledge the packet sent by the host. Okay, so we can actually see when we have a valid configuration. CFGOK will not be set if the endpoint size parameter is bigger than the DPR. What? Oh yeah, right. The RAM I can access from the CPU. A clear of EPNN acts as an endpoint reset. Okay. Configuration of the endpoint is kept. Wait. Clear acts as an endpoint reset. Also performs the next operation. The configuration is kept. Resets the data toggle field, whatever this field does. The DPRAM memory associated with the endpoint is still reserved. Okay. Okay, I'm gonna need to configure the direction. Let's see if we have some UECFG. I'm gonna guess it's down here somewhere. UECon, there we are. Okay, these bits configure the endpoint type for the selected. Yes, EP type, we have the control type. So it stays 0. Direction. I don't think, control endpoints are bidirectional. So we can just leave this one be. The 1 is this one. Reserved. EP size. These bits configure the endpoint size for the selected endpoint as shown in this table. What size do we need? I have no idea. Just Google it. USB control endpoint size. Size. Yes. The packet length of control transfers in low speed devices must be 8 bytes. High speeds allow for all of this, and full speed must be 64. Wait, how much do I have? Overview. You know what, I'm just gonna set it to 64 because why not? If it doesn't work, I can change it. Down here. So we need this one to be, wait, I'm just gonna, yeah. So the first one has to be, what was it? 0, 1, 1, so 3. 3. Let's go. Next one. EPBK. These bits configure the number of banks that is allocated to the selected endpoint as shown in table. Okay. 1 or 2 banks. Does a control endpoint need 2 banks? I'm just gonna go with no. Okay, 1 bank, 0, 0. That was easy. Alloc. Writing this to 1 allows 1 to allocate the specified amount of memory for the selected endpoint. Writing this bit to 0 allows to free the previously allocated memory for the selected endpoint. So we need this 1. So this one has to be 0, 0, 1, 0, 2. 2. Oh, and whoopsie. You need to read this one. What does it do? Allocate 1x64 bytes to endpoint 0. Yeah, seems sensible. And then we can test the correct endpoint configuration. Yeah, I know how to do that. Just gonna enable the wait, I didn't set the 0 register. Yeah. 0 register has to be set here. Let's go. So enable the port again, and then make an infinite loop. Yes, I can type. Jump inf loop. Yes, okay, seems sensible. Yeah, okay. Now we need to make an if statement, something similar. So, wait, no, we don't. Wait, let me split keyboard driver. I am very sure that we have something like skip next statement if bit is set. So I'm just gonna copy this one over. paste it here. Let's see where we have this. CFG OK. CFG OK. Yes. You are bit number 7 in this register. Right. Okay, yeah. And you are a 7. Okay, the next right, if this bit is cleared, we will skip the next instruction. No, I'm pretty sure we have to is that a thing? Let's look it up. SBIC skip if bit in IO register is set. Let's go. So if this is set, we're not gonna execute the following line, which is rjump inf loop, and it will jump straight into the loop. So if everything is done correctly, which probably not, we should have a blinking port. Just gonna gmod plus x /dev /tty. Okay, make that did not work at all. Line 19. What do you mean? Clock select. Wait. Didn't it work last time? It didn't, right? Uh-huh. But why didn't it work? Where's my AVR library stored? Let's see. I have no idea where this is. Okay, this is not cool. Where is my AVR/IO.h? Yes. Mm-hmm. Mm-hmm. How to find? Yeah, that seems. It's for Windows. No. That's not a solution. Find Atmel dear Linux. No. What do we have? Lib. Lib seems. No. Do I see Atmel? I do not. It's the same thing. Nice one. Whoopsie. Slash user. Okay, I'm getting depressed. This is so not working. It's not a folder, it's a directory. Yes. Okay. Where is my path? So what you're saying is I can just do this. I can not do this. I may be able to do this. No, I'm just gonna. Yep. Didn't think so. Where could it be? It's not in the Perl. It's not in the Java. It's in the bin. Let's go. ls/user binary. Yes, please. Never mind. Oh, AVR. Let's go. Haha. Which one is it? Which one? Which one of you nerds? Do I have a libc? Do I see a libc? I do not see a libc. That's not good. AVR GCC. What? Oh, they are programs. Right. Yep, those are binary files. Obviously. It's in the binary file folder. What did I expect? It's not here either. What does the AUR say? Right now, it's in packages. AVR libc. Okay, where is it installed? This doesn't help, does it? View the file list. Yeah. User AVR. Wait, do I have that? Oh my god. No. Include. Wait, no, lib. Lib. Which one are we using? Let's just go with 31. Maybe. You know what? We're gonna go to the include. Haha. No IO yet. I don't see any math, local, int types. I could import int types, that seems. stdio, stdlib. What is in there? No, actually. A lot of comments. That's what in there. Still commented. Oh. Okay, yeah, some weird shit. We have. Oh yeah, this is all C. Yes, please. I see a lot of IO. Do we have 8u2? If we have this chip, which I am currently working on, we are talking about the Atmega8u2, which we should be able to U2. I am a genius. Now, if I'm searching for USB driver, clock select. Just CLK select. Yeah, I don't see why we shouldn't be able to use this. Clock select. So we do have the clock select, yes, but it doesn't want to compile. Now, why is that? Does it not like having 3.5 there, which would be confusing? But hey, okay, we have a just right here, which one is not even described. So how do we set? Why can't we set this? Like if I make getting operand out of range, which is interesting to say the least. Line 19. 176. What is 176? Should be 3.5, right? I think we checked this last time. 172 hex. B0. Wait, what? Line 19. So 18 down. Where is anything B0? What is happening? Can I set this to R0? Does this change anything? Like 0 can't really be out of range, right? Okay, that's not the problem. I guess. Google it. It's basically just using Google anyway. Oh, AVR, let's go. Yeah, okay, that's gonna be a bit difficult. Because this is not 8-bit. Did it say something about just writing it with like 4 bits? Like what? What's the plan, Bucko? What is going on? Okay. Good one, okay, yeah. AVR. Let's see. Seems pretty straightforward. There's no point in setting the stack pointer yourself. Yes, okay. I can see that. Okay, what now? Oh, that can't be. That is not the reason. Alright, this is writing to RAM. I'm not writing to RAM. This is very strange. Wait, what lines do we have? 19, 23, 26, 27, 29. So there's a gap between 19 and 23. Whoopsie. Yes, okay, that makes sense. Wait, no, it doesn't. Why does the PLL CSR work? Would be line 21. Wouldn't it? Yeah. You don't get an error for line 21. What is up with the PLL? Whatever the fuck. PLL, where are you? PLL CSR. PLL CSR. Don't really see how this is any different than, you know, this one. Except maybe there's an undefined bit in the middle. We have another one that's not throwing an error. Error. I don't know. 23, 26, 27, 29, 31, 34. We have something after 34. Yes. No. We do not. Wait, 34 is throwing an error? SBIS? What is going on? 206. What is 206? I don't have 206. What is 176? B0 was it, right? 176 in hex. B0. That should fit in here. Did clock select 1? Wait. Am I... Clock select 0. What is your problem, dude? Okay, this is very strange. Do I have to unlock it first? But that wouldn't be an assembly error. The error would be somewhere, would just be a runtime error. So I'm setting this one to what was it? 3.5. Yeah, that should work. I don't. And where is it getting this B0? Or 176? What is going on, dude? Okay. I don't really see why you should not be working as intended. Which operand is out of range? Like, what? You know what? I'm just gonna... Whoops. Wait, why didn't that work? Now. Same thing here. And yeah, then I can ignore this. So now we should be back to the blinky example. And it works. It just works. Now, am I allowed to do this? I am. Well, of course. Am I allowed to load this with zeros? Of course not. Wait. We have the register descriptions here. Should be a bunch. What was that? No idea. Now we're talking. Interrupt vectors. Yes, okay. Constants. RAM start, yes. RAM size, yes. RAM end, yes. Fuse memory size. Fuse clock select. Wait. Can I set these in software? That would be funny. High fuse extended lock bits. Okay. Signature. Sleep mode. Okay, that's SFR. True. No. Where is this defined? Yep. I'm gonna look into the Maybe here? No? What? Why? SFR define, okay. SFR defs. Okay, yeah, there's gonna be a bunch of these. Wait, what am I using? SFR IO address. So I need to... Wait, am I way too loud? No, this seems kind of... Okay, maybe a little bit. Okay, this is better, yeah. I'm gonna search for SFR IO address. So SFR is SFR minus the SFR offset. That's a thing. Does it have the wrong SFR address or offset? So that way we end up at B0 because okay, this is the big brain time. Watch this. 176 was B0. The real one is D0, so it's 20 off. Or 20 off. Now if we were to put in the 41, huh? What's it gonna be? 29. What was the problem with the 41? It was line 23. Line 23 was this one. PLLCSR. We're gonna PLLCSR. Yes, and we are at 29. Wait. 49? 29. Okay, this one is correct. But it could be 49. It's the real one. And we have D0 as this one. So we currently have 29 and 49. And then we have 184. Let's see. 184. B8. What is it? I should have probably 184 was line 26. Line 26. USB con. D8. What do we have? B8. So we are off by 20 again. So this does seem like the issue. Like for some reason these registers don't have the correct... Wait, is that a bug? USB con D8. Oh, is that because of you SFR mem? What does DDR have? It has IO. These are two different functions. So the PLL is also IO. Okay. The mem, SFR mem, has an issue. Now we're talking. Wait. Okay, yes. These are all the defines. Yes, we know. More. 16. Wait, what? You can't just use 16. That's not a thing. Okay, yeah, I'm gonna look at this again. Yes, okay. Okay, now we're talking SFR mem 8. So our SFR offset seems to be 20, but it has to be 0. Wait, no. Mem 8, mem address, mem 8, mem address. Why does only the SFR IO get the offset? I know the... Oh my god. Oh my god. This is so annoying. Jesus fuck. Okay. Did that work? Probably. USB driver S, okay. Yeah, we need to, instead of IO address, we need to change this one to mem. You know what, I'm gonna... wait, no, that's not the right one. This one. We need to change, right? Wait a second, what? Okay, we're gonna need to okay, now we're talking. So this one needs to change, if I remember correctly. So this one also, probably this one. Gonna guess this one, and also this one. Fuck. Did it just get worse? Why? $208 is 20 more, I guess. Right? 208 should be like DB D0. Wait, this should be correct. Clock register. Why? What is wrong? D8 is the correct one. Am I losing it? How hard am I losing? SFR mem address. It's literally just the SFR. What is going on? Wait, I can't use out. Oh my god, that's... How do I write this? I'm losing it. I already lost it, dude. Data transfer. Okay, here, please. Wait, memory. What is memory? Is that RAM? Please don't tell me it's fucking RAM. I'm gonna lose it even more. Jesus. What does the brackets mean? Cool. Yes, please. More. Program memory. Yeah, no. Do we have like actual memory? No. Okay, cool. Data data transfer instructions. What do we have? Load indirect. Copy register. Load immediate. Load direct from data space. Load indirect. Just gonna try move. Let's just try with this one. Hey, it is move. Move actually works. Okay, good to know. You know what? Yeah, you know, I coulda probably done this one a little bit smarter. Okay, now we should be. Now we should be. What the fuck did I change? I thought this was working. Why aren't you working now? One register number or name or number from 0 to 31 required. Oh wait, we got the same error last time. Okay, yeah, never mind. We can. I don't know. Can we use this data space we're talking about? I don't think so. Where is this? Do we have like? General purpose registers? This isn't it. This is like the IO register, right? Aha. These are the standard ones. General purpose working registers. Wait, why do we have so many? R26 to R31? Okay. Then the XYZ stack pointer. Okay, yes. Stack pointer high and low. Instruction timing. Okay, Okay, this is reset and interrupt handling. Interrupt response time, AVR memories. Aha! Is this what we are talking about? Extend IO memory, yeah, okay. First, next is standard IO, then 160 of extended IO. I think this is what we are trying to write to. Internal SRAM, just general RAM, I think. 5 different addressing modes for data memory covered: direct, indirect with, okay, yes. So we're trying to reach this one. And 1F is less than 41, right? Should be here, 29. Wait, what? Yeah. But so we are trying to reach these. How do we access them? Only with these. Wait, 60? No, we're below 60. I am maybe accessed by the LD, LDS, LDD. Okay. And the IO space, yes. The IO registered within the address range are directly bit accessible, yes. In these registers, the value of single bits can be checked. Yes, refer to the instruction. When using IO specific in and out, the IO must be used. Okay, yes. When addressing data, 20 must be added to it. Okay, so we have LD and ST. ST, what is? Where? LD, load indirect. Seriously, I have to set the... I'm losing it. I already lost it. Ooh, I lost it. What? Where? Okay, yes. Okay, we only need to load the lower one. Please, fucking why? Why do you do this to me? We can use the LDS. Please. LD and ST instructions. Wait, LDI. Does this work? Does it somewhere specify this? Like, is LD part of the LD family? Wait, So the LDI should work. Load immediate. You know what? I'm just gonna try. Yeah, I guess this does not work. Yep. So instead we need to LD load direct from data space. What is the ST store indirect? This is the write operation. Can I just STS? This doesn't work. Match case, please. 1 byte from a register to data space. This data space usually blah blah blah. Okay. How do I write this? STS number register. So STS number register. Oh my god, it works. Yes. Oh yes, I can't do this. This is bad. We have something like STS for general purpose registers. Change flow instructions, relative, indirect. Wait, no. Wait, maybe? SBIS, yes. And I O register, if bit in register, SBRS. Yes, this is what I need. So, oopsie. SBRS. But first, need to load this into bit 16. So LDS would, right? LDS 16. Oh, same thing here. Yeah, I'm gonna look up how this works. 1 second. Load indirect. Wait, where? LDS, yes. RDK. Okay. So R16. Right now. Oopsie. I don't know how to clear the search. This should be here, right? Now this should work. SBRS. R16. Oh, and R16. Same thing down here. R16. $23. Number must be positive and less than 8. What did I do? Line. Wait, what? Oh, I am very smart. This should be LDS. This should be SBRS. No compiler errors. Oh my god. Ooh, it feels so good. Now, make send. Okay, didn't crash. Didn't crash yet. Still have hope. Now, do we have it toggling so we know that something works? Let me plug in my ground as reference and probe the pin. Let's cross the fingers. Well, I do have something toggling. Try on channel 1, please. And it's 4 megahertz. That seems correct. Guys, people, I think we have configured something that works. How insane is that? Now I have no idea if it actually works. Oh, yeah, fuck. Sudo mod 777/dev tty, and that's we celebrated too early. Okay, now we can actually make send. Now we're gonna probe again. And it's not toggling. Seems like we forgot something. What could that be? I have no idea. I'm gonna go sleep. So, yeah. Tomorrow I'll be off. Maybe on Wednesday. Don't know though. It's a strong maybe. Wait, no. Let's just say I'm off for 2 days. Later, nerds.